All right, so in this video, we're going to learn about special right triangles. Let's start off with the right isosceles triangle, otherwise known as the 45-45-90 triangle. Now, in order to understand right isosceles triangles, we can take this square here, in which all sides measure 1, and cut it in half diagonally. And so now what this gives us is a right triangle, and not only is it a right triangle, it is a right isosceles triangle because each leg measures 1 unit. So I removed the other half of the square here so we could focus in on our right isosceles triangle. And remember that in an isosceles triangle, not only are two sides equal, but the two base angles are equal, are congruent. And so since the two acute angles of a right triangle are complementary, and these two angles are congruent, that means they each measure 45 degrees. Which is why this triangle is also called the 45-45-90 triangle. And so the diagonal of the square is the hypotenuse of this triangle, and we don't know what it measures. We know that each leg measures 1 unit, but we don't know what the hypotenuse measures, but we can use the Pythagorean Theorem to figure that out. So we say, all right, a squared plus b squared equals c squared, and a and b are both 1. And we know that 1 squared is 1, and 1 plus 1 is 2. So c squared equals 2, which means c equals radical 2. And so now we can take these 1s and replace them with x's, and this gives us our formula, our relationship between the legs and the hypotenuse of all right isosceles triangles. The legs are x, and the hypotenuse is x radical 2, which means if you know the measure of a leg of a right isosceles triangle, all you have to do is multiply it by radical 2, and that gives you the measure of the hypotenuse. So for example, if I have this right isosceles triangle here, and I know that one leg measures 5 units, I know that the other leg also measures 5 units, and that the hypotenuse measures x times radical 2, so 5 radical 2 units. Or if I have an isosceles right triangle and one of my legs measures 3 radical 2, then I know that the other leg also measures 3 radical 2, and then the hypotenuse is x radical 2, right? So we have to multiply by radical 2. So we say 3 radical 2 times radical 2, and radical 2 times radical 2 equals 2. Whenever you multiply a radical by itself, you basically break the radicand, the number inside the radical, you break it free. So this becomes 3 times 2, which is 6. So what if I know the hypotenuse of a right isosceles triangle and I need to find a leg? So what I need to remember is that the legs are x and the hypotenuse is x radical 2. And what that means is if I multiply the legs, the measure of one of the legs by radical 2, that gives me the hypotenuse, which in this case is 10, and I can write that as an equation. So I'm going to focus on leg AB here, and I'm going to write the equation AB times radical 2 equals the hypotenuse, which is 10. Now, in order to solve for AB, I need to get rid of this radical 2. So I'm going to multiply both sides by radical 2, because radical 2 times radical 2 equals 2. So on this side, radical 2 times AB radical 2 becomes 2 AB, again, because radical 2 times radical 2 equals 2. And on this side, I have 10 radical 2. And then to solve this equation, for AB, all I have to do is divide by 2. And so AB equals 10 radical 2 divided by 2 is 5 radical 2. And so that is the measure of the legs of this triangle. 5 radical 2. In this next example, we see that the hypotenuse is 5 radical 6, and we need to find a leg. Again, we know that in a right isosceles triangle, the measure of one leg times radical 2 equals the hypotenuse. So I can write this equation. Let's use RS. So we're going to say RS times radical 2 equals the hypotenuse, which is 5 radical 6. So then, in order again to get rid of this radical 2, I need to multiply both sides by radical 2. So on the left, I get 2RS equals 5, and radical 6 times radical 2 is radical 12. Now here, I can actually simplify radical 12, because radical 12 comes from 4 times 3, and 4 is a perfect square. So I can rewrite this as 5 times radical 4 times radical 3, because 4 times 3 is 12, right? And then I could simplify this because I know what the square root of 4 is. It's 2. So this becomes 5 times 2 radical 3, and 5 times 2 is 10. And finally, to solve for RS, I just need to divide by 2. And so we see here that side RS measures 10 radical 3 divided by 2 is 5 radical 3. So now let's talk about 30, 60, 90 triangles, and we can use an equilateral triangle to understand those. So we know that in an equilateral triangle, all 3 sides are equal. So let's say that they measure 2 units each. And we know that all 3 angles measure 60 degrees. So now let's go ahead and draw a perpendicular bisector from this top vertex. And this gives us a right angle here. And since we bisected this angle, we know that this side, well, basically both sides, are 30 degrees because half of 60 is 30. But I'm just going to look at this side here. And this gives us our 30, 60, 90 triangle. Now, looking at this right triangle, I see that the hypotenuse is an original side from the equilateral triangle. So I know it measures 2. And this shorter leg is half of the original side of the equilateral triangle. So I know it measures 1. Now, we don't know the measure of the other leg, but we can use Pythagorean Theorem to figure that out. So let's go ahead and do that. So a squared plus b squared equals c squared. We'll call this leg a squared, so 1 squared plus b squared equals c squared, so 2 squared. 1 squared is 1, and 2 squared is 4. We subtract 1 from both sides, and we get b squared equals 3. So if b squared equals 3, then b equals the square root of 3, or radical 3. So that is the measure of this leg, is radical 3. So now, if we replace this 1 with an x, that makes the hypotenuse 2x, and that makes this leg x radical 3. And so this is the relationship between the legs and the hypotenuse in a 30, 60, 90 triangle. So then we can apply that. If I have this 30, 60, 90 triangle here, and I know that the short leg measures 4, that tells me that the hypotenuse measures 8, because the hypotenuse is twice the length of the short leg, and my longer leg is 4 radical 3. Or if I know that the longer leg of a 30, 60, 90 triangle is 7 radical 3, then that means that the shorter leg is 7 and the hypotenuse is 14. And that's because the shorter leg is x, the longer leg is x times radical 3, and the hypotenuse is twice the shorter leg. So if the longer leg is 7 radical 3, then the shorter leg is 7, and the hypotenuse is 14. What if my hypotenuse is something like 4 radical 3? So how do I find the sides? Well, let's think. Again, the shorter leg is half of the hypotenuse. So if the hypotenuse is 4 radical 3, then the shorter leg is 2 radical 3. And if the shorter leg is 2 radical 3, then the longer leg is the shorter leg times radical 3. So we can go ahead and say 2 radical 3 times radical 3. And again, radical 3 times radical 3 is 3. So we get 2 times 3, and that equals 6. So this longer leg equals 6. So let's go ahead and take a look at the trigonometric ratios with these special right triangles. First, the 45, 45, 90. And since we're doing the ratios, remember SOHCAHTOA. So you remember what the ratios are. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, with a 45, 45, 90 triangle, since both acute angles are 45 degrees, then the work is easier because it's cut in half, because you really only need to find one angle. So let's go ahead and do sine, the sine of the 45-degree angle. Right? That's going to be opposite over hypotenuse. So that's going to be 1 over radical 2. Now, when we have a fraction like this, we do not want the denominator to be a radical. So the way we take care of that is very easy. Just multiply both parts of the fraction by the radical that's in the denominator. So I'm going to multiply both parts of this fraction by radical 2. And so this becomes 1 times radical 2 is radical 2, and radical 2 times radical 2 is 2. So the sine of the 45-degree angles is radical 2 over 2. Now, so what's the cosine? Well, the cosine is going to be the same exact thing, because even though it's adjacent over hypotenuse, both legs are 1. So you end up with 1 over radical 2. And when you multiply both sides or both parts of the fraction by radical 2, you end up again with radical 2 over 2. And then tangent is opposite over adjacent, and both legs are the same. So that's 1 over 1, which equals 1. And you could tell that that's going to be the case with every single 45, 45, 90 triangle, that tangent's going to equal 1, because the legs are the same. What if we change the measurements? Does that change the ratios? Well, let's take a look. If I know my hypotenuse on this 45, 45, 90 triangle is 10, then what are my side lengths? So remember that the hypotenuse is equal to one of the side lengths. All right, we'll just call this x times radical 2. So if I say here x times radical 2 equals my hypotenuse 10, because remember how we did this earlier in the video, we want to get rid of this radical 2, so we're going to multiply both sides by radical 2. And this gives us on this side 2x, and on this side 10 radical 2. And so when we divide by 2, we get that x equals 5 radical 2. So that's the measure of both sides here. Both legs is 5 radical 2. So let's go ahead and do our ratios and see what we get. So sine of the 45-degree angle, opposite over hypotenuse. So this is going to give us 5 radical 2 over 10. And then I can actually simplify this fraction. Think about if the radical 2 wasn't there and you just had the fraction 5 over 10. you could simplify that to 1/2. So this would simplify to 1 radical 2, or just radical 2 over 2. Hey, that looks familiar. And we know that cosine is going to be exactly the same thing, because they're the same numbers, right? So that's also going to equal radical 2 over 2. And the tangent, since it's 5 radical 2 over 5 radical 2, we know that that equals 1. So we can see that even if the numbers are changing, the ratios remain the same. All right, so let's go ahead and take a look at the ratios with a 30, 60, 90 triangle. So first, if this short leg is 1, then what's the hypotenuse? Let's double that, right? So it's 2. And the longer leg is 1 radical 3, or just radical 3. So now we can go ahead and fill in our ratios. So let's take sine of the 30-degree angle. So that's opposite over hypotenuse. So the sine of the 30-degree angle is here. Opposite is 1. Hypotenuse is 2. That's 1/2. Now remember what we learned when we learned about sine and cosine, the relationship they have, that the sine of one angle, of one of the acute angles, is equal to the cosine of the other acute angle. So if the sine of the 30-degree angle is 1/2, then the cosine of the 60-degree angle is also 1/2. Now let's take the cosine of the 30-degree angle, which is adjacent over hypotenuse. So that's going to be radical 3 over 2. And this one does not need to be simplified because the denominator is not a radical. So that's it right there. It's radical 3 over 2. And again, the cosine of one angle is equal to the sine of the other angle. So then the sine of the 60-degree angle is also radical 3 over 2. So now let's take the tangent of the 30-degree angle. So tangent is opposite over adjacent. So opposite the 30-degree angle is the short side 1 over the long side radical 3. So that's 1 radical 3. Let me put it here. 1 over radical 3. And so now this one needs to be fixed because the denominator cannot be a radical. So we're going to take care of that very easily by multiplying both parts of this fraction by radical 3. So 1 times radical 3 is radical 3, and radical 3 times radical 3 is 3. So the tangent of the 30-degree angle is radical 3 over 3. And now the tangent of the 60-degree angle, so that is adjacent over opposite, and that's radical 3 over 1, which just equals radical 3. So in the last part of this lesson, we're going to talk about Pythagorean triples. A Pythagorean triple is a set of positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. This means that a, b, and c are the legs and hypotenuse of a right triangle. So a Pythagorean triple is a combination of 3 whole numbers that make a true right triangle. Now, the most common Pythagorean triple is the 3, 4, 5 Pythagorean triple. So if we plug this into our Pythagorean theorem, a squared plus b squared equals c squared. So this will be a, 3 squared plus b squared equals c squared. Well, 3 squared is 9, and 4 squared is 16, and 5 squared is 25, and 9 plus 16 is 25. Now, any multiple of this combination also forms a right triangle. So if I multiply by 2, that gives me 6, 8, 10. If I multiply by 3, that gives me 9, 12, 15. If I multiply by 10, that gives me 30, 40, 50. And all of these are right triangles. So if you can identify a Pythagorean triple, then you could very quickly find the measure of a missing side. So for example, in this right triangle here, one leg is 27, the other leg is 36, and I'm looking here and I say, well, 27 divided by 9, that's 3, and 36 divided by 9, that's 4. Oh, look, this is a 3, 4, 5. So then the hypotenuse is 5 times 9, which is 45. Now, some other Pythagorean triples are 5, 12, 13, 7, 24, 25, and 8, 15, 17. And you can find a bunch more if you just look them up online. All right, I hope that this video, this lesson has helped you to understand the special right triangles. So 3, 4, 5 make the Pythagorean theorem true, which means that they form a right triangle.